So the interior angle sum. If we have a triangle here, and one of the first things that you should always remember when you're looking at situations like this is nothing is ever drawn to scale. That means even though an angle might look a certain way, it may not be accurate. I can tell you that this is going to be a 40-degree angle. Now I don't know if that is the case for the actual triangle that you're looking at, but for our purposes we're going to call it a 40-degree angle. I can also say that this one is a 60-degree angle. So the question I'll ask is, what is the remaining value? Simple enough. Like I said on that first slide, the sum of all of the interior angles of a triangle is always 180 degrees. So what we're saying is that 40 plus 60 plus this x, whatever that is going to equal 180 degrees. Combine like terms. 100 plus x equals 180. Subtract 100 from either side, and we find that x equals 80 degrees. Fairly simple, I think. So let's move on and do another triangle. This time let's change it up a little bit. We're going to make this angle simply be x. And we're going to make this angle twice as big. We're going to call it 2x. And then finally, we'll take a look at the last angle, and we're going to call it 3 times as big as the first one. It's going to be 3x. What's the measure of each angle of the triangle? Well, the same rule that we just talked about still applies. The sum of all of the interior angles of a triangle is always 180 degrees. So x plus 2x plus 3x equals 180 degrees. Combine like terms. We have 3 plus 2 plus 1, or 6x equals 180. Divide both sides by 6, and we find that x is 30 degrees. Hey, that's wonderful. We now know one of those angles. We know this one, but we still don't know the other two. Well, if the first one is 30 degrees and the second one is 2 times x, 2 times 30 would be 60 degrees. And then finally the last one, 3 times 30, that's 90 degrees. And if we add these 3 numbers together, you do get 180 degrees. So those 3 numbers are the measures of the 3 angles in that triangle. So let's do one more involving interior angle sum. This time, let's involve a variable, but not on all of them, just on one. Let's make this first angle, let's say this one will be an 85-degree angle. I know it doesn't look like an 85-degree angle, but like I said earlier, we always go by what's written, not by what it looks like. That's called not being drawn to scale. And we'll make this angle over here we'll make it 25 degrees. And finally, this last one, we're going to make it 4x degrees. What's the value of x? What's the value of this angle right here? Well, we're going to find both of them. Once again, the sum of the interior angles is 180 degrees. So 85 plus 25 plus 4x equals 180. 25 and 85 added together will be 110 plus 4x equals 180. Subtract 110 from both sides, and we find that 4x equals 70. So x apparently equals 70 over 4, which reduces to 35 halves. And if we want to plug 35 halves back into this original statement, we find that the measure of that angle is 70 degrees. So I can write the answer this way: 70 degrees and x equals 35 halves. Let's just put a comma in between to make sure that it's clear, and I'll put a nice box around it. So that's how interior angle theorem works.